And these have square roots in the bottom. Okay, so off to the side, we can put the key idea is the idea of difference of squares. Okay? If you want to get rid of a square root, you need to square it. If you want to get rid of a binomial that has a square root, you're going to need to multiply. And here is the other language that comes up with this. Okay? These in math has nothing to do with verbs in French, are called conjugates. Strategy that you hear math teachers say is multiply by the conjugate. And this is where language comes into mathematics. Often when you're learning math, you watch the teacher do the pattern with the numbers, you understand the pattern with the numbers, and you replicate it. That is a very typical thing that happens in math. And then you wait 2 days, and you can't remember how to do it. Okay? That's a very typical math thing. Oh, I could do it when I saw the teacher do it first. I could replicate it, but it didn't stay in my memory. Okay? Things that help keep things in your memory. One is we call things by their name. This is called a difference of squares, and factoring a difference of squares. And I can tell you, if you can remember those words, factoring a difference of squares, you have a better chance of remembering what it means. But if you have trouble factoring this, you probably also don't remember what it's called. So that's something that you can do with any subject matter as you're studying. Learn the language, and remembering how to do it is easier. So here's language here. This is a difference of squares. We call the factors of a difference of squares conjugates because one has a plus and one has a minus. And whenever you multiply two conjugates together, you always get a difference of squares. So the strategy when you want to get rid of a square root is you need to multiply by the conjugate. And so if you have that strategy and you know what it means, that we are able to, in part A, I have 4 plus 2 root 6 over 3 root 2 minus 4. I want to multiply by, on the bottom, I need to get rid of that square root. So the conjugate would be a 3 root 2 plus a 4, and then I'd have to multiply the same thing on the top so that you can see that that purple fraction is equal to 1. And when you multiply by 1, right, doesn't matter how bad your times table is, your ones timetable, you like can nail that, like 27 times 1. Oh, wow. Like that is phenomenal, right? We got our ones timetable. I don't know if you spend time at home practicing it. Like, oh, I'm going to get up to 928 today. 928. Yes, right? It's super easy to times by 1. It doesn't change the answer. Now, when we times by 1 here, we're not changing the answer. We're just changing how the answer looks. And our goal is not to have any square roots on the bottom. So what do we have to do here? If I'm multiplying these together, somewhere I lost a pen. Oh, here it is. If we multiply these together, so I'm going to add brackets on here to remind myself, I have to multiply these, I have to multiply these. And this is where Now, what we did in grade 10 for multiplying things out, for foiling, we have to be really good in grade 12 because it's just like one little part of this. Now, on the top, they're different. So I'm going to have to go through and multiply it all out. How do I multiply with radicals? I multiply the numbers in front, so 4 times 3 gives me 12. Then I multiply the radicals. Since there's just one, you just have 12 root 2. Then 4 times 4, that's 16. 2 root 6 times 3 root 2. Well, the 2 and the 3, that will give me 6. And the root 6 and the root 2 will give me root 12. And then 2 root 6 times 4, well, I multiply the 2 and the 4 to get 8, and then I just have a root 6. On the bottom, if you recognize that it's a difference of squares and you understand that, please use the shortcut. You know that it's just going to be the first one squared minus the last one squared. 3 root 2 times 3 root 2. That's going to be, well, 3 times 3 is 9, and the root 2 times the root 2 will be 2, minus 4 times 4, 16. So we don't have to FOIL or multiply out the bottoms. If you do, with all the arrows, because you feel more comfortable doing that, it's perfectly fine. But if we understand a shortcut, it's nice to use, right? Just like now that I've taught you that 29 times 31 is just 30 squared minus 1, you'd probably want to use that strategy as opposed to multiplying it all out by hand. Okay. Oh, I want to show you more cool stuff, but this is fun math anyways. So now we need to finish our question by simplifying it completely. Do we have any like terms? Can we put things together? Can you see that on the bottom of this fraction, we have 18 minus 16, that our bottom of our fraction, we can definitely simplify to make it 2. On the top, do we have any radicals that are the same? Can we add these together? In order to add radicals, they have to belong to the same family. This is part of the root 2 family. This is part of the root 6 family. What family is this part of? You might want to say root 12, but when we talk about families of radicals, we also learned that we had to simplify our radicals. So root 12 is actually part of the root 3 family. How do you know that? Because root 12 is 4 times 3. So we have to go 12 root 2 plus 16. And now that this is, root 12 is 2 root 3's. Okay, are you okay with me saying that root 12 is 2 root 3's? Because it's root 4 times root 3. And square root of 4 is 2. So that means I can bring a 2 out in front. That 2 hits this 6, gives me 12 root 3's plus 8 root 6's. So when simplifying, we have to make sure that all of our square roots or all of our radicals are in lowest terms as mixed radicals. So we had to change the 6 root 12 to a 12 root 3. And again, we have to check, are any of these like radicals or like terms? Can we put any of them together? The answer is no, because they're all different. Then finally, we have to say, oh, I've got a 2 on the bottom. Is this fraction in lowest terms? Or can these 4 terms on the top, can they be divided by 2? They each can be divided by 2, so that means my final answer will be 6 root 2 plus 8 plus 6 root 3 plus 4 root 6. And this is simplified. Okay? Technically, for the mathematician without a calculator, right? This, the 5 minutes that we did to write it like this, now if we needed to find this answer by hand with a decimal, would take us probably only 45 minutes instead of 3 hours. Does that sound like fun? You want me to teach you how to do square roots to 5 decimal places by hand? Yeah. Look it up on Google, on the internet. How to figure out a square root of 2 by hand. There is techniques. It's not pretty. It takes some time. And then if you had to divide by the original one, oh my goodness, then the hours start to pile on for doing things by hand. Now, I'm not saying that that wouldn't be enjoyable. I do like to do some good mental math every once in a while. But for our purposes, this is where we're going to leave it as a simplified form. Let's look at the second one. So B, what do we have? We had 6 root 2's. No, I'm on the wrong one. We have 2 root 3's minus 4 root 6's. And currently it's bad because we have 3 root 2's plus 2 root 3's on the bottom. We're not allowed to have square roots on the bottom. So, switch colors here. I'm going to need to multiply the bottom by its conjugate to make a difference of squares. Because if I can square the first one and square the second one, my square roots would go away. So it will have to be a 3 root 2, a 2 root 3, but since this one has the plus sign, mine is going to have the minus sign. So the sign different in the middle is important for the difference of squares. And if I multiply the bottom by that, I have to multiply the top by that, so I'm multiplying by 1, because multiplying by 1 doesn't change my answer, just changes the way that it looks. So I'm going to add brackets here. Are you okay this time that I'm only going to draw the arrows on the top, and I'm going to do the shortcut on the bottom? So on the top, two root 3 times 3 root 2. Multiply the numbers in front. 2 times 3, 6. Two times 3, 6. I have color issues. I need it to be in blue. 2 times 3 is 6. Then 3 times 2 would be 6 as well. So I have 6 root 6. Then the last ones. 2 times a negative 2, negative 4. Root 3 times root 3. Are you okay that I do the shortcut here? Root 3 times root 3 is going to be root 9. I'm just going to write a 3 in brackets, because whenever you multiply a square root by itself, the square root's going to go away. Then I have minus 4 times 3, minus 12. Root 6 times root 2, root 12. And finally, minus 4 times minus 2 would be plus 8. And root 6 times root 3, root 18. On the bottom, I have my difference of squares. So it's the first one squared, which will be 3 times 3, 9. And root 2 times root 2 will be just 2. Okay? Minus, because it's a difference of squares, I square the last one. 2 times 2 is 4. Root 3 times root 3, that'll just be 3. Can I simplify things? Absolutely. I'd start on the bottom because that's my easiest mental math. 18 minus 12, are you okay that this will be a 6? And then on the top, are there any of them that I can reduce? I can't reduce a root 6 family. 4 times 3, that'll be 12. But a root 12 is your root 3 family. Can you see that your root 12 is 2 root 3's? So then that 2 is going to get multiplied by that negative 12. It's going to give you negative 24 root 3's. Can you see the 18 is also able to be simplified? It's part of your root 2 family, because 18 is 9 times 2. So root 18 is 3 root 2's. You remember the activity? Yeah, remember that activity where we showed that 3 1 root 18? That activity was to give you an idea of why these things are equal. So if this is 3 root 2's, and that 3 would get multiplied by the 8, you'd have 24 root 2's. So we make all of our radicals into lowest terms, which means writing them as mixed radicals in the smallest family member that's possible. Can you imagine if families were really called that? Think about does anyone have a younger sibling? How much younger? Just 2 years. Anybody have like a lot younger? Like 5 years younger, 10 years younger? How much? And so how old are they? How big are they? About this big? Okay. So, and what's their name? Vienna. So imagine everybody in your family now gets referred to as you're about twice as big, you'd be 2 Viennas, right? We have to refer to all of our family members according to the smallest family member and how many of them you are, right? Right now I'm about 2.5 Carsons. My youngest, well, he's getting, I'm still probably about 2.5 Carsons. So I'd have to be called that by the smallest family member. That's what we're doing right here. And then finally, none of these are from the same families, so we can't put any of them together. But we look at the numbers. There's 6 of these, 12 of these, 24 of these, 24 of these. We're dividing by 6. Is there a number that divides each of these numbers in front and the number on the bottom? Is there a number you can divide all of them by? What's the biggest number? 6. So we divide them all by 6. That would leave me with just root 6. That would leave me with minus 2. Here, minus 4 of these. And plus 4 of those. Now, I'm not saying go home and divide your family members by 6. That would be, right, that would be a scandal. But this is, put a circle around it, our final simplified answer. So when I said that the word simplify in math gets very complex, you can see it's true. I don't know, they should be called make your lives easier in a complicated way. Because technically, this would be easier to calculate without a calculator than it would have been to begin with. But your idea is sort of like, well, I can just put it in my calculator both ways. What's the big deal? Well, we are practicing learning how to do this. So, questions for practice. Was this not the longest lesson on one question ever? But I hope that the activity at the beginning, trying to find the one that worked, and then focusing on the definitions right now, will help you remember this idea. Yes, we, I mean, There we go. Triple I. 13, because we did 13 I, and now we're doing I. Okay.